Okay, so now we're going to do a real life problem. Not just a made up thing, but something that we actually might care about. We want to find the component form, so we're now on page 50, number 8. We're going to find the component form. Wait, what does that mean? Find the component form. What am I looking for? Coordinates. So I'm looking for x and y. So I need to find an x and a y that correspond to a plane flying at a speed of 410 miles an hour on a bearing of 200. Oh Lordy, bearing. That goes back to our compass. Remember? So compasses are labeled differently than real math or normal math. Compasses, remember, start up here and go this way. Okay, don't shoot the messenger. I didn't make up the rules. It's just the way it is. We got to deal with it. When we're doing navigation, so it says the word bearing, then we got to use this framework. This is our compass framework. Now it says our bearing is 200. So that would put us right here. Would you agree with that?
Yeah.
So this angle is 200. Remember we took a test and you had to draw this? So there it is. Now the magnitude is 410. So the length of this is 410. The speed is the magnitude. And you need to find the x and the y. We've already done problems like this today. What am I going to have to be careful about when I find my x and y? They're both negative. Pay attention to which quadrant you're in. Your components are going to both be negative because you're sitting in quadrant 3. Now, to find x and y, we use sine and cosine, right? But I need an angle. Well, I'm not going to use 200. I need this
70.
angle right here.
70.
That angle is 70. Would you agree with that, kids? Would everybody agree that angle's 70? And that's the one I need, because that's the one that's inside my triangle. So I'll say cosine 70 equals x over 410, and sine 70 equals y over 410. Is that okay? So then x will equal 410 cosine 70, and y will equal 410 sine 70. Now, I'll type those in, remembering that when I write them down, they have to both be negative. So 410 sine 70 is 385.27, and 410 cosine 70, negative 140.23.
So like when we type these into the calculator, like they're supposed to be positive when they come out, right?
They'll come out positive. Yep, they'll always come out positive. And then I marked it down before I even started. But I got to remember, since this is in quadrant 3, they have to both be negative.
I know I really didn't listen before, but I put in like 410 sine 200 and I actually got negative 140, 220.
Okay, you got lucky because the angle matched up with the standard form angle. That won't always happen. Okay? So you want to make sure you're typing in an angle that your calculator understands. Your calculator does not understand the compass. Your calculator only understands normal angles measured like in math.
All right, that makes sense.
Okay. Actually, they should have been reversed. You should have gotten them reversed.
Yeah.
Yeah. it doesn't work when you type in the compass heading. Because you got these numbers actually turned around. Now, you did get them both negative, because 200's in quadrant 3, but they were reversed.
Okay.
This gave you, the cosine gave you this, and the sine gave you this. So you got it wrong. You need to have this answer. This is the right answer. Okay? So, Max said I wasn't paying attention, and I used 200. Bad idea, because 200 is not a standard position angle. And anything that goes into the calculator has to be in standard position. So please use 70 if you want to get the right answer. All right, let's try the same thing. Now we have a speed of 510 and a bearing of 310. Okay, this one's going to come out different too. All right, so I'm using my compass headings. Where is this vector? It's a bearing of 310. It's going to be actually in quadrant 2. 310 is going to be out here, right? So this angle is 310 degrees.
Sorry, she's 12.
Okay? Now, I know I need my component. Oh, and I know that's 510 long. The speed is the magnitude. So I need to drop my perpendicular and make my triangle. Now, before I can do it, I need to figure out what that angle is. So let's think about this. Let's not blurt out stuff. Let's really think about it. We know that all the way around to here was 310, right? How far is it to here? Well, how far is it to here? All the way around to here would be 270. So how much farther did I go? 40. That's a 40-degree angle. The angle you need is 40 degrees. Okay? We have to just use our logic. So, here's x and y. This time, what's going to be negative? X. X is going to be negative. So, cosine 40 equals x over 510. And sine 40 equals y over 510. So I'm going to type that in on my trusty calculator. Oops, 510. 390.68 negative.
Yeah. And then 327.82.
Yep. Now let's interpret those two numbers. You got this plane, here's the airport, and this plane is taking off at that speed and that bearing, okay? And let's say he crashes right there. How far west is he from his original location? 390.68 miles west. And how far north is he of his original location? 327.82. That's exactly right. Awesome. One more. Quit looking at the clock. You're going to be out of here soon enough. A football is thrown at a 53-degree angle with the horizontal. So here's our football thrown at a 53-degree angle with the horizontal. Right? And the speed is 12. And remember, speed is magnitude. Find the components of the velocity vector. So one more time, we're finding x and y.
Yeah.
All right, go ahead and do that.
Yeah.
Is that what you got? All right. Please make sure that your plates and napkins and forks and crumbs are thrown away. Let's not leave a mess for the next group.